My name is Claire, and I'm going to be helping you with problem number 77 in chapter 13 of The Principles of General Chemistry by Silverberg textbook. All right. Now, this is a problem regarding the colligative properties, specifically in this one, the freezing point depression, okay? So we have a formula, all right? The change in temperature of freezing, all right, is equal to I, which is the Van't Hoff factor, times this freezing point constant that's specific to a particular substance, all right, times M, and that's molality, all right, not molarity. Molarity you're used to dealing with and have been dealing with for a while. It's moles per liter. All right, molality is very, very similar, except for we're dealing with moles per kilogram instead of liter, okay? So this question, I'm going to write down our givens first, all right? We're given that the freezing point of benzene, all right, which is the solute that we're working with, all right, usually is 5.5 degrees Celsius, okay? What is the freezing point of a solution of benzene? When we have 5 grams of naphthalene, all right, dissolved in it, all right, and we have 444 grams, all right, of the, benzene, or, yeah, the 444 grams of benzene that we're dealing with, that we're dissolving the naphthalene into, okay, so, grams, all right. So the first thing we need to do is naphthalene. We're given in the problem that it is C10H8. So we'll need to compute a molar mass, all right? The molar mass of naphthalene is 128 hang on, excuse me. 128.6 grams per mole, all right? So we're going to go from our given in grams, all right, 5 grams, C10H8, all right, times 128.6 grams per mole, all right. If you like to be very specific, right, this is where you're multiplying it by the inverse molar mass, all right, to get, and this is the unrounded number, so if you're concern for significant figures, this is absolutely not what you need. We get 0.0390137 moles C10H8 that we are dealing with, all right? So a molality, we want moles per kilogram, okay? So we're given the amount of benzene in grams, so we'll just move over the decimal point a little bit, all right? 0.444 kilograms, and it looks like we are just about ready to start applying our formula, okay? So, all right, we have change in temperature is equal to I. All right, this is, I'm gonna talk a little bit about the Van't Hoff factor I. The Van't Hoff factor is a measure, is basically a correction factor for our colligative properties formulas where our non-electrolytes have a Van't Hoff factor equal to 1. We don't need to correct them because the correction factor is electrolytes electrolytes compared to non-electrolytes. So in the case of naphthalene, all right, it's just a hydrocarbon. It is a non-electrolyte. It does not, change. It does not dissociate in water. So we just have I is equal to 1, right? So when we apply our formula, we're going to just go ahead and put a 1 here. It's unitless. It's just a correction factor, okay? All right. Now we need our, we need our constant for our benzene, all right? I didn't write this down earlier, forgive me, I'm sorry. All right, the Kf of benzene is equal to, is equal to 4.9 degrees Celsius per molality, right? Go ahead and put that in here. 4.9 degrees Celsius per molality, okay? All right, times our, where's my formula? Molality, all right? We have, okay, moles, all right, we found this out here. Moles of our solute, all right? Per kilograms solvent, okay? Our 0.444 kilograms benzene that we're dealing with, all right? 0.444 kilograms, all right? Everything cancels out nicely here, all right? We've got our inverse molality over our molality numbers. We're searching for temperature, and here you may be asking, okay, degrees Celsius, I thought we were always supposed to be using Kelvin for problems like this. In this case, since we're dealing with a difference in temperature and Celsius and Kelvin scale linearly, we can just go ahead and use Celsius and not care. So it makes it really easy for us, okay? Just plug and chug. Most of you will be using calculators for this problem, so it's, you know, no issue for you here. Just 4.9 times 0.03901 over 0.444, all right, gets us a difference in freezing point temperature of 0.43056 or units in degrees Celsius, okay? So, all right, a common problem here would just be to go ahead and repoint this delta value here, but don't do that, okay? This formula is for a difference in freezing point, all right? So we want to go ahead and start with our initial freezing point, all right? And this formula is for freezing point depression. So what we're going to do is we're going to go ahead and start, and then we're going to use our difference here, subtract it because we want the lower value because it's freezing point depression, okay? All right, which gives us an adjusted freezing point of about 5.1, okay, degrees Celsius, okay? So, and it's as easy as that. We are now done. We have found our new freezing point for benzene when we have 5 grams of naphthalene dissolved. It's as easy as that. And now I'm done.